In this video, we'll be covering the graph of tan and we'll sketch it for this particular function between negative pi to pi. The first thing that we want to look at here is the 3. This 3 here does represent a dilation away from the x-axis, but that will come out in the wash when we do our calculations later. The next thing here is that we want to focus on the period. And since n is equal to 2, our period for tan is a bit different from sine and cos in the sense that it will be pi over n because it is repeated every half a unit circle rather than a full unit circle. So our period in this case is shortened to pi on 2. Now again, we'll do our basic graph sketch on the outside here. With our mean, this some sort of a maximum idea, but we haven't moved up or down, so we start at 0. But this dilation of factor of 3 here, I'll show you, will happen or show soon. We'll start from 0 for our start, and the end of our period will be pi on 2. Again, we're going to do quarter increments. So if we split this in half, we'll end up at pi on 4. If we split it in half again, we'll end up at pi on 8. 3/4 of the way, we multiply that first increment by 3, we get 3 pi on 8. Now what does our graph actually look like? We start at 0, 0. Our asymptote will be halfway, so that happens at x equals pi on 4. And we'll end up back at the same spot there. This 3 here is our dilation factor. So instead of that 1, we're going to jump up to 3 like so. Same with this 3 pi on 8. That's where negative 3 will exist. So that's the graph of our tan. So if we look at 0, 0, that's our starting point. Let's plot that in. Our asymptote is at pi on 4. So I'll jump across to here. Might do it in a different color. I'll use pink. Pi on 4 for our asymptote. As soon as you draw your asymptote line, write down the equation of the asymptote to prevent you from forgetting. Halfway between that is where our increment of 3 will exist. So if this is a y value of 3 up here, our graph will increase ever so quickly, but still go towards the asymptote. And this segment of pi on 2 and 0 is one complete cycle for pi. Again, halfway between the asymptote and that point will be our negative 3. And this will be a curve that approaches the asymptote again. Now, what happens here is for every other increment between negative pi to pi, it will just repeat. So if I cheat a bit here by grabbing the part of this graph, let's see if it works. If I repeat it like so, in a different color, then we can produce the remainder of our graphs for the remainder of the domain. From there, we can just label our graph. So we've got negative pi 0, we have pi 0, negative 2, negative pi on 2, 0, and pi on 2, 0. Now you can see here that our asymptote will repeat every period. So if we add pi on 2, or it's the same as pi on 4, 2 pi on 4, we will get to our next asymptote, which is at 3 pi on 4. If we subtract by 2 pi on 4, we will get from pi on 4 down to negative pi on 4. So x equals negative pi on 4. And if we subtract by 2 pi on 4 once again, we will get to our final asymptote there. So we have our x-intercepts and our endpoints, and we have the equation of the asymptotes that accompany the asymptote lines. This dilation factor of 3 comes out in the sense that it is quite steep, a steep approach, because it is dilated away from the x-axis from 1 all the way to 3. Likewise, down below, it's dilated by a factor of 3 as well.